Okay, today we're looking at the operation of multiplication. Now, I emphasize the operation of multiplication because it's not just multiplication. We have to recognize that it is an operation. So we saw from our previous videos what an operation is, right? An operation is a procedure that produces a new output value from one or more input values, right? And the operation of multiplication is multiplication. Will produce a new output value from one or more input values. It's a binary operation, just like addition. In fact, is closely related to addition. Most basic definition of multiplication is repeated addition. And for some people, that's the only definition they think of for multiplication. But as we see, there's a little bit more to it than that. We've actually already seen this as we try to understand the place value system, right? A frequent situation talking about place value, we'll use some symbols here. So here's an apple and another apple, and here's a bag of apples. Okay, how many apples is that? Well, we're counting up groups of 10 and groups of 2. I have 3 10s. Why isn't the pen? There we go. 3 10s and 2 1s. And if I toss in a bushel of apples here, there we go. Let's make a few more of these. There we go. So now I have 5 of these, and so on, right? That's what multiplication means. I'm counting up by hundreds, so I can count 100, 200, 300, 400, 500. $10, $20, $30, and 2. So there's a 3-digit number, 532. But this doesn't only apply to multiples of 10 or powers of 10 more precisely, right? If I'm buying eggs, our family eats a lot of eggs. There's 6 of us, and they're good cheap protein, right? So every Friday, I guess Saturday, we get our produce delivery. We get 3 dozen eggs. Come on here. 3 dozen eggs. But sometimes we have some left over from the previous week. So let's say we've got 4 eggs. How many total eggs do I have? Well, 3 dozen means I have a dozen plus another dozen plus another dozen plus 4 means I'm adding 4. 12 plus 12 plus 12. I can use the associative property, associate all my 2's. 2 plus 2 plus 2 is 6. 10 plus 10 plus 10 is 3, right? That's how we do multi-digit addition. So there's 36 plus 4 more. So I have 40 eggs total. With this expression, we see I'm not taking 3 16s. I have 3 12s, and then I'm adding 4. Instead of having to write out all of those 12s, it's more compact to write it in this way. So that's even more true when we get to bigger numbers. If I have 57 times 43, it's really annoying to have to do 43 plus 43 plus 43 plus 43 plus 43. Lining up all of those 43s would take a really long time. And it's a pain to have to add, okay, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, and count up 57 threes, and then have to write the number and carry. So we have an algorithm for multiplying this that's based off of at least remembering your single digit multiplications. If I have to do 7 threes, on here, 1, 2, 3, 4, 5, 6, 7. That's a little tedious, but I can do it, right? 6, 9, 12, 15, 18, 21. Okay. If we have 7 times 3 memorized and we can avoid this, fantastic. But I'm certainly not going to ask you to memorize what 57 threes is, let alone 57 43s. Right? That's why we have our system, our computation system for doing this. This will be explained in a future video. For now, we're just talking about what multiplication is. Right? So multiplication is repeated addition in this context, in this sense of having discrete countable items. But as we've talked about before, we're not just interested in whole numbers. We need to be able to handle fractions and decimals and variables, right? Values that we don't even know their size. And so that's where we look at something more like this. Whatever this is, I'm going to call that 1 unit. And I can have multiples of that unit, so I can copy and paste that, I think here. There we go, copy, paste. There's another one. So there's 2 units. There's 3 units, and so on. But we don't always end up with exactly 2 feet or 3 feet or 4 feet in length, or with exactly 1 gallon or 2 gallons or 3 gallons. Or whatever we're measuring in, it's not always going to come out to exactly 1 unit. So what we often do is we'll take that 1 unit and stretch it by some factor, right? Or shrink it. Come on. Shrink it by some factor. And that stretching or shrinking is determined by multiplying. If we multiply by some number that's not a nice whole number, maybe we're 1.5 times as big, or a growth of 10%, 1.1 times as big, right? That growth factor is still multiplication. And that's our second definition here. Come on, the cursor's not cooperating today. There we go. So think of that as dilation, which is a fancy word for growth, or say stretch, or contraction. Right? If we're multiplying by a number greater than 1, that's going to grow things. If we're multiplying by a number between 0 and 1, that's going to shrink things. Once you bring negatives in, that doesn't really apply to this definition. That has more to do with addition. We'll talk about that later when we do our video on sign numbers. All right, our third definition of multiplication is actually more fundamental than dilation or contraction. Right? Historically, whether it's the place value system or the Roman numeral, right, XXX, for 30. Repeated addition is kind of the beginning of multiplication. But before we dealt with fractions or anything that wasn't a whole number, we first got into this third definition, which is to change the dimensions or the units of the term. And that's pretty clear when we look at some other pictures here. So if I've got 3 units here, and let me actually do this. Put one more here. All right. If I take these and I rotate them, thought there was a way to do that. I can flip it. On the smart board, I can rotate it. I think here, I'm just going to have to draw a new one. So I'll just draw a new one that's going to be the same length. If I take that same arrow and I go down instead of to the right, I can create a rectangle, right? I can take that same unit go around in a rectangle going up, it's not as straight there, right? And I get the perimeter, 2 plus 3, that's 5, 6, 7, 8, 9, 10. But as soon as I switch from going around the outside to start talking about how many of these squares I have, let's get better here. As soon as I start counting those squares, I'm now talking about a different type of unit. I'm talking about a different thing, a different measurement. I'm no longer talking about how many 1-inch sticks I need. I'm talking about how many 1 by 1 squares I need to fill up this area, right? And so once we go from length, once I go from length, which is 1-dimensional, to length times width, which is 2-dimensional. How did I do that? I used multiplication. I'm saying 3 on one side by 2 on the other, and that gives me 3 times 2, which is 6. Now, we can be a little confused here when we're talking about discrete objects. If I'm taking my apples and just placing them on the table in this array, I can count 1, 2, 3, 4, 5, 6. I'm just counting in groups of 3. I have 2 rows of 3. Or we're seeing already that multiplication is commutative, right? 2, 3 columns of 2. Both of those are giving me 6 apples. That's still repeated addition. I'm just laying it out in a pattern instead of counting 1, 2, 3, 4, 5, 6 straight in a row. This is not repeated addition. I'm not counting how many dots are showing up in a row. I'm looking at length by width. And so this doesn't have to be the whole number 3. That could be 3.1. And this could be 2.5. I'm still going to multiply length and width. This could be pi, and this could be e. I'm still going to multiply length by width. E and pi are both irrational constants. Pi, I assume you've probably heard of before. Right, so there's changing dimensions. Changing in units, that's where conversion comes into play. Right, so think of distance equals rate times time. right? That rate is how you translate time spent sitting at cruise control into distance in miles, right? We're converting from hours into miles. How? By multiplying by this rate, this miles per hour rate. So we're going to do a lot of unit conversions. We're going to do a lot of stuff with fractions. But for now, the big idea is that multiplication is the operation we use to change dimensions or units within a term. And if we're just dealing with the same units, or with no units at all, just the raw numbers, it's either talking about repeated addition, if we're talking about countable things, or more generally, it's stretching or shrinking. So that's what multiplication is.